Now, what is the steps in ultrasonic testing? This is a very important thing. What are the steps? What is the advantage? And what their main working principles? That all are main required thing in your examinations or in your subject point of views. Okay. First one is a step. First step is surface preparations. Okay. So clean the surface to remove the oil, dirt, rust, or coating. If anything is there, we must have to remove that all first. Okay. Apply the couplant, I mean the gel, water or oil to ensure the proper transmissions of sound wave. Because if they are just simple or they are clean, smooth, dry, then it could not get transmit the wave. That's why we must have to apply the gel, water or oil to ensure the proper transmission means what? They can cross the wave. I mean if they cannot cross, they will be just returning. Okay, so for that we must have the transmissions of the wave. Step one is the first one is this. I mean, for every techniques we have the first one is the preparation or surface preparation or sample preparation, you can say in general way. Second one is the transducer positioning. Place the ultrasonic probe on the surface of the test material. Choose the correct frequency and the wave mode based on the material thickness and detect the types, defect types. Okay, so what kind of the defect it could have? According to that, we can apply the frequency. Okay, and their wave. So it depends over the material thickness and what kind of the defect that we are basically going to find out. Okay, that will decide your frequency level. Okay. Step third, the sound wave transmissions and reflections. So the transducer sends the ultrasonic waves into the material. The waves reflect off internal features, defects, or the back walls. If there is any defects, then it will return back from there. So we can, uh, you know, uh, uh, through the computer that we can detect at what location they have returned, and so it is having a defect. And different size also it can be detected with the help of the computer, where I mean how they have, suppose you have like this is like a material, like here you have a kind of this kind of defect. Okay, suppose inside the material we are not able to see through the nectar, or it is not on the surface but it is on the inside the material, suppose. Okay, so once I mean for every part, suppose this all area will be reflecting the like this, they're reflecting the wave, right? So reflecting will be collected over the computer, and for that they will make a shape, and that shape will be similar to that of the defect, so that we can easily detect the defect, and also the size and their pattern we can easily detect. We can easily able to find out. Okay. Fourth one is the signal interpretations. So the returning waves echoes are displayed on either oscilloscope or digital screen like in the computer and all that. Okay, the technicians analyze the signal amplitude, time delay, and pattern to identify the defect. These all are the steps you can easily we can easily detect the size of the defect, position of the defect, and all that. Okay, the step fifth is reporting and documentation. I mean, we just need to record the size of defect, depth, and locations, generate a report for the quality control and maintenance planning, so that we that we can sorry, remove that problem. Okay, the defect.